All right, hello, Science 10, here with your lesson for today. We're still on thermal energy. We're going to be talking about heat here. So heat is the thermal energy that flows from higher temperature to lower temperature, right? Everything wants to be balanced, right? It doesn't matter if we're talking about temperature or voltage or pressure. Things want to balance out, right? So with heat, we want to go from a high temperature to a lower temperature. We're going to try and balance out. And we have something that we need to know called the specific heat constant. Okay, so depending on your given material, be it water, wood, steel, whatever it is, each substance will have its own coefficient, right? Its own property. And that is the amount of heat energy that would be needed to raise 1 kilogram of that material by 1 degree. So, for example, water has a specific heat coefficient of 4,184. You don't need to memorize these. They will be given to you. Any sort of coefficients like that or constants will be given to you. So you don't need to memorize them. Okay. Thermal equation. This is what we're going to use to determine how much energy is going to be needed or how much heat is going to be needed in order to change something inside your material, right? So we've got this formula here. It's pretty easy to remember the formula because it's just Q equals MCAT. That's the way that I was taught how to remember it, and it stuck with me ever since I learned it, right? So Q equals MCAT. Well, what are all of these different variables, right? So let's start with some of the easier ones that we know for sure, right? So mass, M, makes sense, right? Mass, we're going to be measured in kilograms just because that's the base unit that we want to work with here. Now, C is this constant, right? C for constant makes it easy. So C is our specific heat constant. Okay? And this is measured in joules per kilogram Celsius. Okay, it's a bit of a weird unit, but it's joules per kilogram Celsius. Now this triangle here, you're going to be seeing this more and more as you move into science, okay? Now this triangle represents the Greek letter delta. Delta means change in, okay? So what this means for us is change in temperature. So delta T means change in temperature. And how do we find this change in temperature? We take our T final, whatever our final temperature is going to be, and we subtract it by what we're starting with, right? So our change in temperature, right? If you want to take water out of the tap and you want to boil it, right? Whatever that change in temperature is, versus do you want to take ice cubes and take it all the way up to boiling, right? There's going to be a much bigger change in temperature there, right? So delta T is the change in temperature. And then our last one, Q is our heat energy. And if you recall from last year when we were talking about electricity and power and things like that, energy is measured in joules. Okay, so these are all of the pieces here for this formula. So let's just go through a quick example. Erase all this. Okay, so I wanted to know how much heat is needed to, let's go with boil water that has been frozen. right? So we're going to take our ice cubes, we're going to put them into a pot, and we're going to boil it. We're going to see how much heat energy do we need, right? And how much of this do we have? Let's say we put in 2 kilograms worth of ice cubes. Okay, now one of the important things here is it is frozen, so I'm going to say that our initial temperature is 0 degrees Celsius, okay? And in order to boil water, water boils at 100, okay? So now what else do we have here? We have our mass, which equals 2 kilograms. And again, you don't need to memorize this. It will always be given to you, unless you're being asked to find it, of course, is that specific heat coefficient, or specific heat constant, sorry. And again, in water, it's 4,184 joules per kilogram Celsius. And the reason why I'm writing down all of these units is I really want to make sure that once everything is done and all of the units cancel out, that I'm going to end up with the right units for my answer, right? So let's write down our formula here. Q equals M cat. Okay, and again, we were looking for Q. So Q equals 2 kilograms times 4,184 joules per kilogram Celsius. And we're going to be timing this by delta T. So in this case, delta T, I'm going to write it down in a little separate spot here. Delta T equals T final minus T initial. I made it pretty easy for this one. It's just going to be 100 minus 0, right? So 100 minus 0, which equals 100. So this is times by 100 degrees Celsius. Okay, so if we start this off here, one of the first things I want to do is see if my units will cancel. So let's see here, kilograms divided by kilograms, this will cancel out. Celsius divided by Celsius, that'll cancel out. And that just leaves me with joules, which is what energy should be. Okay, so our units all cancel out, which means that everything's been put in the right place. Now I just have to go through multiplying some integers. So I've got basically Q equals 2 times 4,184 times 100. Okay, so, and this is going to be in joules. So let's have a look here, a little bit of quick mental math. 2, so that's 8, 6, put the 1 up here, 3, 8, and then we're multiplying it by 100, so we've got 2 extra zeros here. All right, so it should take us 836,800 joules of energy to take 2 kilograms of ice to boil it. 2 kilograms of ice is a lot of ice, mind you, right? That's like 2 big of those bags that you can pick up at the store, right? That is a lot of ice. But still, that's a lot of energy, okay? So again, with formulas, you can be asked to find Q, you could be asked to find M or C, or one of the pieces inside delta T, right? You'll always be given all but one of the pieces that you need. And then the job is to find the other piece. So you may be required to rearrange the formula a little bit. You would have done that type of stuff before with, say, like density or with Ohm's law or something. Okay, that's it for today. It is a bit of a longer video. I didn't want to show a specific example in there, so it did take a little while. But that's basically it. All right.